never should have agreed to sign every copy of this software.
Wait, I know. I can use my paper tool. I can put my paper tool wherever I want it signed, and the machine will come and sign it for me. Today we'll make a custom signature paper tool that signs your name wherever you place it under the video camera attached to your CNC router. Okay, so far this just looks like a piece of paper. How do we turn it into a paper tool? Gotta cut it out, of course, and I'd like to put it in some kind of wooden frame. I'll make a new paper tool. I'll just call it frame. Let's have the AI create this paper tool. So I'm gonna say, let's make this frame with an inner rectangle and an outer rectangle to cut it out. And I'm gonna define this frame by a bottom line I'd like to cut between these 2 points that define the corners of the bottom line, and a distance above the bottom line that's perpendicular, and that defines the inner rectangle. This is the part we see. Then we have a frame thickness, and I'll ask the AI to define a frame thickness parameter, which lets me adjust how thick I want the frame to be, essentially defining just the offset between this inner rectangle and the outer rectangle that we use to cut out the frame. And lastly, I'll want a depth parameter to cut through the entirety of my material. Okay, send. So the AI is going to respond, and it's going to give me an answer that includes, here's how to make your paper tool. But look, it's also generating all the code that I need. This is Python code, and so we're going to paste that into our Python paper tool. Now look, it's going to show you how to use the frame tool that it just created. So first, let's grab this code, and I'm going to copy it from right out of this AI window here, and I'm going to copy it into a new Python file. So that, like I said, this is a Python paper tool, so I can create a new Python file, and I can paste the Python code right into the Python file. Okay, that's it. You don't have to save it. So what I'm going to do is put this paper tool ruler on where the bottom of the frame is, and then a rectangle will extend. That's the viewing rectangle. Okay, 2.75. Now we're going to navigate to letters A and G. So paper tools is driving the CNC machine using the video camera, and it's putting these blue squares. You can see the computer vision is finding these 2 targets. Okay, if you remember what the AI produces, this frame, and that's how I'm going to use it, but I'm going to go letters A to G, and I'll use a height of 2.75. That's what I measured. Now for the frame thickness, I think I'm going to go with a frame thickness of just about 3/4 of an inch. So I put that in, and the depth is, the material is 1/4 of an inch, so I'll go a little bit beyond that. Let's say 0.27, and I'm done. I'll add a 1/4 inch downcut router bit, which is what I'm using. And here I can preview my G code. Now this is the G code that's output by paper tools from our frame instruction. Okay, let's run it. So here's that inner rectangle, and now let's do the outer rectangle. I just want to say I'm doing it at a weird angle to show that you can. We don't have to be aligned with the axes of the machine. You can see that 3/4 we used for the frame thickness. That's the distance between the 2 rectangles. And let's try it out. Okay. Yep, fits. Great. Okay, time for some pizzazz. Paste it in here, flip it over, purple it up, and there we have it. A paper tool in a paper tool frame. I find some of these other frames like protractors, rulers, these different things are handy to have around. Let's try it out. I'm going to navigate to letters A and B that are in the paper tool. Now while we're looking at this, that line that says paper tool sig is how we activate this paper tool. The computer vision will pick that up, and so it'll automatically be inserted into the project frame we capture. Let's run it. It's not looking great in just wood. But you know the idea is that we could sign some great piece of art or whatever we're making. So let's do that. Well, all right, I don't think we're winning awards here, but look, I'm a software engineer, so software engineer art it is. All right, let's try it on copper. Maybe that'll look cool. I mean, look, we're making things, so we want to stay in our flow. Let's try things. Let's try it on copper. So I'm going to position the paper tool like I did before, and I'll tell you a little more about navigating. So when I click that navigate to all, Paper Tools is going to drive the CNC machine towards these targets, letters A and B in this case. And you can see as it goes, it's moving the router along with the camera to position the camera directly over the center of that square target. Now, Paper Tools already has stored the offset between the camera and the center of the tool, and therefore we know that distance I can change from the camera position to the tool position and always center straight over the square target with the bit. Looks good. Okay, let's run it. I'm deliberately going really shallow because I think I'll do a few passes. I'm not sure how deep I want to go in this copper to get the nice effect of the signature. Hey, if you want a piece of custom signed copper software, leave a comment below, and while you're at it, like and subscribe, and there's a link in the description for where to download Paper Tools. Now, how would you make your own signature? How would you use CAD, let's say Fusion 360, to create a signature and then export it so you can use it in your own paper tool? And what you can see is that I've created these sketches with squares as my square targets, and those are my reference markers around the Paper Tools text. Now I can bring those into a Fusion 360 drawing. So I'll have those squares and I can add labels like A and B. I can even add the little single step that's the Paper Tools sig line AB. By using an underline, that signals to Paper Tools to use that as the code for our step. Then I can do all the usual Fusion 360 stuff, like I can simulate the cam. And as I'm happy with this, I can get ready and export my G-code. Now you're probably wondering, okay, so what do I export and how does that get into Paper Tools? So the first part is normal. You just choose your post processor, name your file, and here's the one exception. I click on Use Subroutines, and you want to make sure that that's enabled. So by posting, I'm going to get G-code where the portion I need is in a subroutine. Looking at the export, I can delete this top part, focus on the internal contents of that subroutine, select all of that except for the very last line, that M99, and that's just signaling the return of the subroutine, so we don't need that. I select all of it, and I can copy and paste that directly into my new paper tool. Before we saw a Python paper tool, this is a G-code paper tool. And I can upload images and PDFs such as a drawing. So I can save that drawing or print it out from Fusion 360 and put it here. That's what you'll print out when you actually want to use the physical piece of paper. So I paste in my G-code right here, and Paper Tools will call this subroutine, and it will also create a preamble with parameters like your spindle speed and other properties of your project. I'll put a link in the description for where to download Paper Tools, and thanks for watching.